this is the second part of 3.6 lesson notes. So what I'm actually going to do is finish the day 1 PowerPoint, and then I'm going to do the day 2 PowerPoint. That one's really short. So yesterday we talked about intersections, so in the previous video, so now in this one I'm going to focus on unions. So go ahead and copy this vocabulary word down right there. So go ahead and pause the video. Alright, so unions, big difference other than when you compare it to an intersection. Basically these are regions that show numbers that are solutions of either inequality. So it's an or, so it's either one or the other. It cannot be both. Whereas an intersection, it had to work for both conditions. With a union, the number you select only has to work for one of them. Okay, now we talked about ands, how it has to work for both parts. We talked about an and basically focuses on the numbers that exist in both cases or work for both cases. We did both of these. You had a chance to try both of those. Now, here we go, ors. It says the solutions of a compound inequality involving or are not always two separate sets. These are rare but not impossible. We don't deal with those. Some numbers may be solutions on both parts of a compound inequality. Those are like some unique cases. We don't really get into those. Okay. Now, what does an or look like? It's a union. And they are opposite rays. So let's look at our A group. The first thing you should notice about our graph here, our diagram, is they don't cross. Okay, a union is not an intersection. It basically says two things and brings them together. So we have A. In group A, it says everything less than 0. So if you look at all these numbers, all of these are less. These are just a few numbers. I mean, there's obviously infinitely many. But here are some that are just less than 0. So here's the first graph right here. Open circle on 0 to the left. Now if you look at group B, this says all the numbers greater than 10. So here's a few numbers that are greater than 10. And here's the graph for that. Open circle on 10 to the right. So the union of these two looks like this. Okay, notice they're not connected. Notice they go opposite directions away from each other. And then look at how you write the answer. You would say x is less than 0 or x is greater than 10. When we did the and intersection, or excuse me, the and compound inequalities, we didn't write the word and there. You can, excuse me, but you don't have to. So it's not necessary. So this is what an or looks like. So it's some number that works either here or here. It doesn't work for both. It doesn't have to. Okay? So let's actually try some of these. Alright. An or inequality basically has an or in them. Now when we get to the absolute value ones, then I'll show you how you can determine whether or not it's an or an and. Because it won't tell you. You have to look at the inequality. But we'll worry about those later. Right now, if it says the word or in there, it's an or. If it doesn't say an or in there and x is in the middle and stuff, and we have to solve it, then it's an and. Okay, so basically we have this inequality and this inequality. I'm just going to solve this exactly like I would any other problem. So I get A greater than 5 or A less than 1. That's my answer. So now for my graph. Now here's where it gets a little tricky. A must be bigger than 5 or A must be less than 1. Whatever A must be smaller than, that means that's your lower bound. That's going to go on the left here. So A less than 1. So open circle to the left. A must be bigger than 5 or greater than 5, so that means it's your upper bound. So we'll put that one open circle to the right. They're both open circles because they're not equal to. And that's it. Notice my graph are opposite rays. They go away from each other. Okay, let's try the other one. Now in this case, we're just going to divide. I'll be very careful here. I'm dividing by a positive number, so I do not flip my inequality. Sometimes you will have to divide by a negative and you will flip your inequality. It still makes it an OR compound inequality, but the difference though is it could change your lower bound to your upper bound or your upper bound to your lower bound. It could switch them. Alright, so here we go. X must be less than or equal to 3 or X must be greater than 4. Now usually whatever is less than is your lower bound, so there's 3. Less than or equal to, so that's closed circle to the left. Or X must be greater than 4, that's your upper bound. Greater than, so it's an open circle to the right. There you go. So these are what the OR compound inequalities look like. They're away from each other. So here you go. You have 2 of them. Go ahead and attempt both these. Go ahead and pause the video. Alright, now that you've had a chance, I'm going to go ahead and do them. Let's see how you did. So we'll start with the first one. I'm just going to rewrite it down here because of how they got stacked. So this is basically a single step inequality. Or, don't forget or in your answer. Yes, you have to write that. Yes, it is wrong if you don't. Yes, I will mark it wrong on a test or quiz if you don't put or there. So you should get r is less than 10 or r is greater than 14. And then for your graph, r is less than 10 is your lower bound. Not because it's on the left, it's because it's less than. It's everything less than 10. It is an open circle to the left. R greater than 14 is your upper bound, not because it's on the right, but because it's a greater than. Open circle to the right. Okay? Alrighty, the second one. Alright, in this case we're dividing, so be careful. We're going to divide by a positive, so do not flip the inequality. Or divide by a positive, do not flip the inequality. Now, I get a -1 here, right? But I do not flip the inequality. Why? Because I did not divide by a negative number. I divided by a positive number. So what if it gives me a negative answer? I am now done. Now let's do our graph. X is greater than or equal to 3, or X is less than -1. Now, remember, the less than is your lower bound. So X less than -1 means -1's over here. And in this case, it's an open circle to the left. X greater than or equal to 3, that means 3 is your upper bound, and it is a closed circle to the right. Okay? So that's what ORs look like. They're opposite. Okay? So we're basically done with this set. Now, the extra element of day 2, or the second part, is basically what we're going to do now is when you're given a graph, can you write the compound inequality? Okay. Now really quickly, everybody hopefully can see these are ands, those are ors. Okay. Ands, X is trapped in the middle and you solve it by working out on both sides. Alright, and notice they have less thans, less thans. Ors literally can have, they have a less than, they have a less than and a greater than. And they have the word or in the middle. Alright, so this is our last example for the second part of these notes. So what we're going to do is we're basically going to write the compound inequality just by given the graph. So let's look at A. Do you see how these are opposite rays? They're rays, they go in the opposite directions. That tells me that's an OR compound inequality. which tells me in my answer here I need to have the word or in it. Now, I know my less than is my lower bound and my greater than is my upper bound. But notice my lower bound is -1 and it's a closed circle, right? So I put an equals 2 on it. My upper bound is on 7 and it's a closed circle, so I put an equal sign to it. So that's my compound inequality for this graph. That's it. That's all you have to do. Let's check the second one. Now you see how it's a line segment? It's connected. That's how I know it's an AND. This is an AND compound inequality. So first things first, I'm going to put X in the middle. And on the left-hand side, I have a closed circle. So that means this less than is an equal to. On the right-hand side, I have an open circle. That means this less than is not equal to. Remember what I said about ANDs. They always have less than symbols on either side of X. They do not have greater thans. My lower bound is 0. My upper bound is 6. So that's it. That's all you have to do. Okay? So we're just going backwards here. So now it's your turn. You have basically 1 minute to 2 minutes. Go ahead and pause the video. Do both. Alright, now that you had your chance, let's see how you did. Alright, starting with the first one. Okay, this is connected. So that tells me this is an AND. Okay, so I'm going to put X in the middle. Now, I can see I have an open circle onto the left, so it's just a less than, and I have an open circle on the right, it's just a less than. My lower bound is -9. My upper bound is -2. So that's my inequality for A. Let's try B. These are opposite rays, so this is an OR. So I'm going to have OR in the middle. I have a lower bound and an upper bound. My lower bound, it's a closed circle, and it's everything less than -3. My upper bound is also a closed circle, but it's everything greater than or equal to +2. That's it. There you go. Okay, so hopefully you got both of those correct, because all we're doing is working backwards. And that's it. So we are done with basically the second part of 3.6.